All right, we're going. What kind of questions did you have off the homework? That was EEF number 2. Go ahead, Mohammed.
23.
23. All right. Oh, that's a good one. Okay. This one looks real intimidating because there's like an awful lot. And it's just basically utilizing the rules of this. Is this about the right one that you're looking at? Okay, so here's the tough thing. Some of you will start seeing stuff that you can start doing right away. Some of you need to kind of go through the whole thing. So I'm going to go do it as the whole thing. So what I'm going to do first is I'm going to highlight all of the things. I'm not going to start reducing anything yet. I'm just going to highlight what wants to move. And I think I have all the negative exponents in there correctly. Okay, so all I'm going to do is I'm going to highlight what is going to switch locations. So when I say switch locations, it's either going from top to bottom or bottom to top. Okay? So now I'm going to rewrite this having things in place. Let's see. So y to the second, y to the third, 2x to the second, x to the second, times 2 over x to the fifth, x to the third, 4 y to the ninth, y to the sixth. Now I'm going to highlight what I moved, just so you, let's see, oh, wrong color. So I moved this, switch locations, this switch locations, this switch locations, bless you, and this switch locations. Notice when it switched the location, went from top to bottom or bottom to top, it got rid of the negative exponent. Is that okay? Okay, so now, yeah, then we can start reducing and taking care of things. So let's, I'm looking just at this. Let's start just reducing numbers. Well, I have a 2 on bottom and I have a 2 on top. Okay? And being that 2 goes into almost everything, 2 also goes into this, and 2 goes into that. So I can assure you right now, we have a 3 over 2. And there might be stuff that we can reduce on top and bottom. So let's take a look at the y's right now. Here are my y's on top. Here are my y's on bottom. So how many y's are up on top? 5. And how many are on bottom? 15. Tug of war. Who wins, top or bottom? Bottom by how many? Cool. Does everyone feel comfortable with that iteration? That's supposed to be a 10. Okay, so we took care of those. Let's take care of the x's now. So I have these x's down here, and I have these x's up here. So how many x's are on top? 8. How many are on bottom? 4. Tug of war. Who wins? Top by how many?
4.
And there's nothing left to reduce top to bottom. Okay, it is literally that easy. The hard thing is, and friends, when I say show as much work as you need to, what really gets goofy is when you start going, oh, okay, I know things are going to move, so I'm going to do this in my head. Things take place that sometimes you might not pay attention to the entire problem. You might think, oh, I'm carrying this really well, and all of a sudden that Snapchat that you need to see comes across your phone. You're like, oh, sweet, yeah, I like that. Okay, or whatever. I don't even know if that's right. But you're going to forget something. Okay, so if you show the steps, yeah, it's great that when I see it, I can see that you're working through it. The tough thing is a lot of times when there's an answer only, it's hard to award partial credit when it's an answer only if the answer is wrong, if I don't see a thought process. It's, you know, it comes from, I'm just going to take a shot in the dark that I'm going to hopefully get something right. Yeah, if you had the 3 over 2 right, you're going to get some points. But if you had 96 over 27, I have no idea where those numbers came from. I mean, they're not even remotely close. So just kind of be aware, yeah, you might want to show a little bit of work. You might, I mean, I have no problem if you had highlighters with you or a different colored pen where you're like, you know what, I can see if I highlight those or I circle them in red pen, those have to move, and then you rewrite it. then it becomes a little bit easier to do. And I think the tug of war analogy is a really good thing. I've used it for many years. It really does work. Kids get it. What really is taking place? I'm subtracting the exponents from each other is what you're doing. But the tug of war is just such a, oh, I get it. Even though someone lost a finger, hopefully no one loses a finger in here doing tug of war. I was doing math. Look, I lost a finger. Oh, jeez. You can't do math anymore. Who knows? All right. Was there anything else off of EEF? Yeah, go ahead. I'm sorry. 19. Okay, yeah, let's take a look at that. That's a good one. All right, number 19. So I have a quantity that is raised to the third power times x y to the third over 4x to the seventh y. Okay. Well, the first thing I want to focus on is just this. I'm not going to start reducing anything at this point. So, okay. I think you're thinking correctly. Let me ask you this. Let me ask you this as a class. 2x is in parentheses. It's raised to the third. So how many 2x's exist up there? 3. I have 2x, 2x, and 2x because of that. Does that make sense? So what I really want to do is I'm going to take this 3 and go, 2 to the third, that's going to give me an 8, and then x to the third. Okay, yes, there's more I'm going to write, but does everyone feel comfortable with what I just did? I went 2 times 2 times 2 to get 8. What's that?
With the x squared, that would be square rooting the, wouldn't that be the same?
Okay, so what I'm going to do is this right here. I'm going to just write over here in blue. This means the same thing as this.
Yeah.
And then this is how I got to the 8x to the third, because 2 times 2 times 2. Yeah.
Why'd you keep it to the third if you already?
Okay, so it's because of this. So on 2 times 2 times 2, that gave me the 8, but the x was also x, x, x. So x to the first, x to the first, x to the first, add the exponents. So the reason that happened is because it was out, the third was outside the parentheses. So it had to apply to everything inside the parentheses. So if it was just 2x to the third and there was no parentheses, that just means x to the third and the 2 is just on its own. But that's just one to look at. Now I'm going to change color. We'll do the rest in red. I don't have any negative exponents, so we're just going to write all the rest that we have. So we have that. Okay? All right. 8 over 4 reduces to 2, so I have a 2 on top. Over, okay. How many x's do I have on top? 4. How many on bottom? 7. Tug of war, who wins? By how many? 3. Agree? How many y's do I have on top? How many on bottom? 1. Tug of war, who wins? By how many? 2. There you go. There's my answer. So that one, the toughest part of that is realizing if I have a quantity, and when you say quantity, that means it's grouped with parentheses. Okay, yes, square brackets work as well, but I'm not going to throw square brackets in at you. Yeah. Oh, yeah. So originally when I said how many x's do we have on top, we have x to the 4th on top, and we have x to the 7th on bottom. If we do a tug of war, bottom wins by 3. Does that make sense? So I was just trying to count through it. All right, what else did you see up here you want to? Number 9, you got it. Number 9, got to flip back a page. Ooh, okay. So I get x to the 0, y to the negative 6, z to the 2nd. All right, so yeah, I'm trying to think how I'm going to say this. If something has an exponent of 0, that becomes equal to 1. If you have 0 raised to the 0, That is undefined. I am not going to throw that at you, but I don't want to do a blanket cover saying anything to the 0 is always 1, because sometimes they might give you a 0 raised to the 0, not in this class, but later. So I don't want to put a blanket copy on that. So if I have something that's raised to with an exponent that's 0, it becomes 1. So this right here becomes 1. Okay, I probably don't have to even write that with the problem, but I will. What about z to the 0? 1.
Did you say that it was z to the second?
Oh, was it? Oh, did I write it wrong? 9, 9, 9, 9, 9, 9, 9. Oh, it is z to the second. Thank you. I'm sorry about that. So z to the second is going to stay up top. Why am I going to move the y down? I have a negative exponent, so there's our answer. That's
Why is the x just negative?
okay. Anything other than 0. If I have x to the 0, 5 to the 0, 2,000 to the 0 power, it's just 1. So if I have a letter or a number other than 0 to the 0, but I'm not going to throw 0 to the 0 at you. If you have some number raised to the 0 power, it becomes 1.
I just thought it would be 0 to 0, because multiplying it 0 times among itself.
You're kind of thinking of it in the right way, but think about it on a calculator. There is a button called log, L-O-G, and the log is dealing with an exponent, and then that's where you're taking place. Someone has got music that's playing a little loud. All right, yeah. Which one? Number 9? Well, I had different bases, so I couldn't add the exponents up. So you got to make sure you have the same base when you add it up. Okay. Anything else? 13. You got it. 13. Okay. That's a good one. Thank you for asking. 13 is a good one because you're dealing with numbers and it starts getting goofy. That's 7 to the second, or 7th over 2 to the 5. Okay, we're going to treat this the same way as if it was a letter. Tug of war, who wins, top or bottom? Top by how much? So I get 2 to the second. What's 2 to the second? 4. So honestly, I would take either of these answers, but there gets to a point where if you have an exponent, or if you have a number raised to an exponent, if it becomes a simple one, go for it. But if you have 13 to the 5th power, that's an enormous number. I'm not worried about that you know how to do 13 to the 5th on the calculator. Just leave it as 13 to the 5th. But if you have 2 to the 2nd or 2 to the 3rd, even 2 to the 4th, I'd say you could probably do that pretty quickly. 3 to the 2nd, 3 to the 3rd, 3 to the 4th, maybe. But anything beyond that, you start getting too big. Okay, the number starts growing too large. And again, I'm not looking on that you know where to find something on a calculator, or if you didn't know how to find a calculator going, okay, 13 to the 5th is 13 times 13 times 13 times 13 times 13. I'm not looking for that. Times 13. So just make sure you're good with that. Everyone good? All right, I'm going to pause this. All right, find that page. All right, so let's just because we had a weekend in between, let's list the rules of the exponents. So the first one is x to the 0, or 7 to the 0, or z to the 0, or 2,000 raised to the 0 equals 1. Okay, and that has to do with something that you'll see later in Algebra 2, which is a logarithm. And a logarithm deals with the exponents. It does have rhyme or reason to it, but we're not going to go and derive why it happens. Yeah.
What if it was negative x?
Oh, ooh. What if we have negative x to the 0, or negative 7 to the 0, or 45 to the 0, something like that? These would all come out to negative 1. And the reason it comes out to negative 1 is the negative here is not being affected by it. If it was a quantity, if it was in parentheses. So you might come across a problem like this. This is going to look a little silly. I actually think this might be a question that's on the test. that whole quantity is raised to the 0 power, the whole thing's 1. No, they're not like bases. So if I have a quantity, a whole thing that's grouped together, that's raised to the 0 power, it just becomes 1. So just know that when there's going to be one that comes up on a quiz. Gosh, I got to look at my calendar. I don't remember where our quiz is. It's definitely not tomorrow, but I got to look. I can't remember. But if I have a whole quantity raised to the 0 power, the whole thing's going to be 1. In fact, I think the one on the test is like 685 x to the negative 2, y to the 5th, z to the negative 200, all raised to the 0. Because the whole thing is grouped together, this whole answer comes out to 1. Okay? Yeah. Yeah. It doesn't matter. Because the whole thing's grouped. So when it's all put together in instead of parentheses, if it's raised to the 0 power, the whole thing becomes 1. Like, I've seen this type of problem listed something like this, where you have 785 x to theta, y to pi, z to negative phi, and you're like, I don't even know what those symbols mean. Well, it's all raised to the 0 power, so the whole thing's 1. So you just kind of, and it actually is a problem that they have on the SAT often. It looks a lot like that, where you have like all these weird symbols going, I've never seen these symbols before. Well, the whole thing's grouped and it's raised to the 0 power, so the whole thing comes out to 1, which is, it's goofy to think about, and you drive yourself a little bit nuts if you sit there and say, but why? I assure you, when you get to algebra 2, it'll be answered. It'll go over how the logarithms work. Okay, but we don't have time to do that. So if I have like bases, so if I had x to the 4th times, and they're multiplied, x to the 6th, then you just add the exponents. That's a 6. Okay, and then there's one other rule where you have the power to a power. So if you had x to the 3rd raised to the 7th, you would go x to the 3 times 7, which is x to the 21st power. Okay, so power to power, you multiply the exponents. Same basis when you're multiplying them, you would add the exponents. And then a negative exponent, will go from top to bottom, or bottom to top, and that's when you're dealing with a fraction. So the negative exponent becomes positive exponent when you move locations. Okay. All right. Does everyone feel? Do we knock these rules out okay? So on the next quiz, I assure you, you'll see something that'll be goofy like that purple one, and you'll be like, oh, but it's all raised to 0, so it's got to be 1. Yay. Anyone need more time on this page? We good to roll? All right. Can I move on? All right. So we want to start kind of thinking about these, and we want to start thinking about a little bit of scientific notation. Okay, so I want to move the decimal 1, 2, 3. So I want to get 3.6 times, how many places did I move the exponent? 3, and I moved it to the right. So I have a negative exponent. Okay, now, a lot of times these negative exponents or these decimal exponents are talking about scientific notation. Scientific notation is a way to take a relatively large number and you create scientific notation so you can put it. So like this next number, this next one, if we want to take it out of scientific notation, I'm going to make it I'm going to move it 1, 2, 3, so I get this for an answer. Okay? This one, that's raised to a 7th, so I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7. So that becomes 18 million. Okay? So scientific notation, again, is something that was devised a long, long time ago to deal with very large numbers or really small decimals. Okay? And it's just one of those things that you do. You will see it in science. The reason that they deal with this is when you're talking about a huge number, rather than taking a huge number times a huge number, you start dealing with the exponent as far as the scientific notation goes. Have you all seen scientific notation at least once in a science class at some point? Okay, cool. Yeah. Well, what happened here is, like, let's say I wrote this out. 1, 2, 3, 4, 5, 6. So if this was raised to the 7th power, I'm going to go 1, 2, 3, 4, 5, 6, 7. It moves the decimal. It's gone. So that's like saying 10 to the 7th. 10 to the 7th is 10, 100,000, 10,000, 100,000, million, 10 million. So you're basically multiplying 1.8 times 10 million. But rather than doing that out, you just realize you're just moving the decimal. If it's a negative exponent, the decimal is going to move. If it's positive exponent, it's going to also move. So just be aware. Okay, so these are a few that we've done. So the first one, I have a quantity raised to the 4th power. So that means I have 2c to the 3rd 4 times. 4, I could realize I can move that here and here. So 2 to the 4th, and then c to the 12th. And 2 to the 4th is 2 times 2 is 4 times 2, which is 8 times 2, which is 16. And I'm pretty sure you're okay to multiply by 2. So 16c to the 12th. And that's what we would look for on that one. If we had 2 raised to like anything bigger than probably 6, I'd say leave it as the exponent. Okay? But you can sit there and just do it. 2 times 2 times 2 times 2 times 2. It's pretty easy to double something. Okay? All right, this next problem, we do have a negative exponent, but let's deal with the negative exponent second. So I'm going to get this. 9, right? Because 3 squared is 9. B to the negative 4. And then I'm going to go here and here times a to the 6th, b to the 12th. Okay, and technically I could put a dot in all those. The b to the negative 4 wants to switch places. It's an a, yeah. So this needed to move, and it moved to right here. Now we're going to just reduce it. Okay, so 9a to the 6th is fine. Tug of war with the b's. Who wins, top or bottom? Top by 8. Do I have to put it over 1? No. Can I? Yeah. But I would just leave that as an answer. Yeah. And sometimes students try to overthink, and you did more work than you necessarily had to. And over 1, I can assure you, is not really that much extra work. But all right, so this one, let's see. This means I have 2p over 5 3 times. So this is going to come here, here, and here. So I get 2 to the 3rd, which we'll figure out, p to the 3rd, which will stay as is, and 5 to the 3rd. 2 times 2 times 2, I believe, is 8. P to the 3rd. And then 5 times 5 times 5. Well, 5 times 5 is 25. 5 times 25 is 125. We happy with that? Okay. All right. Ready to move? Any questions so far? Yeah, you good? Almost? Good to go? Just making sure I had my attendance right. Let's see. Amber never got here. Okay. All right. Can I move on? All right. Oh, no. We have a negative exponent. So we can do one of two things first. Ooh, you like that? All right, let's do that. Notice it is no longer a negative exponent. To the fourth. I'll make it more clear. Okay. So now I'm going to take this and go here and here. So power to power, so I get y to the 6th over x to the 12th. Now, a question that might have come up is, could I have distributed that in and gotten x to the negative 12 and y to the negative 6 and then flip them? Sure. Which way is best? Your choice. Both answers are the same. Okay, it just becomes how you choose to do it. There's no rhyme or reason which way is better or worse. Okay? All right. Thoughts on this next one? What's being raised to the 5th? Just xy. Is the 2 being affected by the 5th? Nope. So that's going to go here and here. So I get 2x to the 5th, y to the 5th. Let me pause there. Do you feel comfortable with what I just did? Okay. And then, ouch, this is going to distribute in. So 3 squared is 9. X to the 2nd, y to the 8. Does that seem okay? Let's finish up. So the 2 and the 9 multiply, give me 18. Like bases, I add the exponents, so I get x to the 7th. Again, like bases with the y's, add the exponents. So 5 and 8, I believe, is 13, unless something changed. Do I got much more?
Class ends in 4 minutes.
Class ends in 4 minutes? That's right. Hey, do me a favor. Bring that back next time. And what I would like to ask you, EEF number 3. Let's start the odds. Okay, I'm not checking it off until the end of the period tomorrow. Okay, so if you need a picture of it, great. If not, I will post it on Schoology. But bring these notes back for tomorrow, and then get a start on the odds on EEF number 3. Does that make sense? Yeah. If you need a picture of it, I have it up here if you want to come take a picture. If not,